Hello, algebra class. This is exciting, right? You get to see my face now by popular demand. This amazing face. Okay, let's see. What are we doing today? Solving equations with variables on each side. So good. Here we go. Remember when we used to solve equations where there would be a variable on just one side of the equation like this, and then we would do something like the subtraction property of equality, and we would get 3m equals 6, and we would divide by 3, and then m would equal 2, right? So this is what we used to do. But we're moving on to variables on each side of the equation. To solve an equation that has a variable on both sides, use the addition or subtraction property of equality to move the variable to one side of the equal sign. For example, if I had x equals, no, let's make this 2x equals x plus 1, then I can subtract x on both sides, right? This is the subtraction property of equality. As long as you subtract by the same thing on both sides of the equal sign, then both sides of the equal sign remain equal. So x equals 1. Boom. Okay. For example, here we have 3w plus 2 equals 7w. So there's two ways we can solve this, right? We could subtract 3w from both sides. And alternatively, we can subtract 7w from both sides. And either way will eventually work. But of course, I would recommend that you subtract the 3w because that is going to be less work. So that gives you 2 equals, oh my goodness, what am I doing? Equals 4w. And the goal is to get the variable on one side of the equation completely by itself, and then the numbers on the other side of the equation completely by themselves. So we'll divide this side by 4 and this side by 4, and that'll give us 1/2 equals w. So now I'd like for you to go ahead and solve this problem and fill out the answer in Edpuzzle. Okay, so you've done some math and you've figured some stuff out, so let's do it together and see if we got the same answer. So I guess it doesn't really matter if you could add 7a to both sides. So this is going to be 12a plus 2 equals 6, and then subtract 2 on both sides. That gives you 12a equals 4. Divide by 12. A equals 4 over 12. Reduce that to 1 over 3. So the a equals 1/3. Here's another example I would like for you to try on your own first. Okay, hope you got a good answer. Let's see what we get. So here we have a x in the numerator and then an x as a next to a coefficient. So what I would do is I would look at this as basically 1/2 x plus 1 equals 1/4 x minus 6. Because that's what this basically means. This is basically a substitution here. And then I would subtract 1/4 x on both sides. And that will give us 1/4 x plus 1 equals -6. Subtract the 1 on both sides. 1/4 x equals -7. Then you multiply by the inverse, right? So we can multiply both sides by 4 over 1 to cancel those out. And then we get x equals negative 28. Oops, wrong one. Okay. Sometimes equations will have grouping symbols, and then you'll have to use the distributive property to remove those grouping symbols, if possible. You know, like we went over in the test. Not all things with grouping symbols can be distributed, right? Like you cannot distribute this. You'd have to say this is x over 3 times 2, which is 2x over 3. Okay, let's look at an example. 8s minus 10 equals 3 times 6 minus 2s, or the product of 6 minus 2s. So we could distribute this, and that would be 18 minus 6s equals 8s minus 10. And then I guess I always prefer to add because I think adding is easier. So 14s minus 10 equals 18. Add 10 to both sides. 14s equals 28. Divide by 14. Oops. S equals 28 over 14. We reduce that to 2. So S equals 2. All right. One last example of the distribution. Go ahead and do this on your own, and we'll be right back. Welcome back. All right. So we would distribute on both sides of the equal sign this time. That's 7n minus 7 equals negative 6 plus 2n. Remember, when you multiply a negative and a negative, you get a positive, right? And then we're going to subtract 2n to both sides to get 5n minus 7 equals negative 6. Add 7 to both sides. 5n equals 1. Divide by 5 on both sides. N equals 1 over 5. Great. Good job, y'all. You did it. Sometimes, whoopsies, an equation will not have an answer. Sometimes an equation will have all the answers. So far we've been looking at examples where, you know, like n equals 3 or something like that, where there's just one answer that makes the equation true. And if n was anything else, then the equation wouldn't be true. Sometimes there's no solution. If you do all your simplification and you get to the point where you get something like x plus 3 equals x minus 3, well, there's no number that you can put in for x where that would be true, right? So this would be no solution. Similarly, if you get to the point where you get to like x equals x, then any number would be true for this equation. So that's called an identity, where all values are true, or in no solution, no solutions, no answers are true. Okay, let's look at some examples. Why don't you go ahead and solve this on your own, and then tell me, is this a no solution or an identity? Welcome back. Here we go. Let's do this. So first, we can distribute this. So that'd be 7x plus 5x minus 5 equals negative 5 plus 12x. Some of you might already know where this is going. So then we have some like terms over here, right? So this is 12x minus 5 equals negative 5 plus 12x. And using the commutative property, we can see that 12x minus 5 is equal to, we can move these two around, right? 12x minus 5. And we can stop here. We can see that both sides of the equal sign are identical. I mean, you could keep going if you wanted here. You could add 5 to both sides and you get 12x equals 12x. And then you could divide both sides by 12 and that would be x equals x. And here we go. This is an identity. Okay, how about this one? What do you think this one is? So here again, we're going to distribute 6y minus 30 equals to 20 plus 6y. And again, you might be able to see what's happening here already. If we use the commutative property, we can move these two around. 6y minus 30 equals 6y plus 20. We can, well, why don't we, I guess, just add 30 to both sides. And then we get 6y equals 6y plus 30. And you might already be able to see here that there's no answer that's going to be able to give us an answer, right? So if we divide both sides by y, here we would distribute the division, right? So y divided by 6 is 1, that's y. Y divided by 30, or 30 divided by 6 is 5. So y equals y plus 5, and that's not going to be true. Yeah, so this is no solution. If you get to the point where one side of the equal sign clearly does not equal the other side of the equal sign, then that's a no solution. So if possible, simplify the expression on each side, then use the distributive property if you need to in order to simplify as well. Then use the addition and subtraction or the multiplicative or division property of equality to move variables or numbers around, but keeping both sides of the equation equal. And then, I guess the important thing to note here is that the addition and subtraction property of equality needs to come first, and then the multiplicative and division property, the multiplication and division property. All right. Hope you enjoyed looking at this face and doing this thing with me. Bye.